Imagine your colon as a lively party full of hardworking cells, immune sentinels, and beneficial microbes all mingling in harmony. It's a well-orchestrated gathering where everyone has a job to do. Some clean up waste, others protect against harmful intruders, and others keep the gut walls strong. Then, sugary drinks arrive at the door. At first, they might seem like welcome guests, bringing a quick burst of energy to the dance floor. But according to new research in Nature Metabolism, these sweet visitors have a dark side. The study shows that sugary beverages, especially those containing both fructose and glucose, can help colorectal cancer cells slip into the party unnoticed and wreak havoc, making it easier for them to spread to distant parts of the body. The researchers focused on how tumor cells metabolize sugar, and what they discovered was striking. A key enzyme called SORD, sorbitol dehydrogenase, seems to act as the cancer cell's bartender, converting sugar into metabolic cocktails that fuel growth and encourage metastasis. Fructose and glucose work together here in a kind of tag team effect. Glucose feeds into energy pathways while fructose is shuttled into building blocks for new cells. Together, they provide cancer cells not just with fuel but with the raw materials needed to make more of themselves and migrate more effectively. This means that what we drink could directly influence not just cancer risk but also how aggressive cancer becomes once it starts. And yet, there's a silver lining here that makes this research oddly empowering. Understanding the sugar-cancer connection doesn't mean living in fear of every sip of soda or juice, but it does show us where we have leverage. Cutting down on sugar-sweetened beverages might be one of the simplest, most controllable steps we can take to keep the colon's party peaceful. In fact, the research hints at the possibility of future therapies that target this SORD enzyme, blocking cancer cells from using sugar so efficiently. Imagine medicines that could selectively deprive tumors of their preferred energy source while leaving normal cells mostly unaffected, a metabolic strategy that could complement existing treatments like chemotherapy or immunotherapy. Another reason to be optimistic is that this study is part of a broader trend in cancer research that is looking beyond genetics and into the microenvironment, metabolism, and lifestyle factors that shape tumor behavior. That means our everyday choices, diet, exercise, hydration, really do matter, and researchers are finally unraveling the biochemical reasons why. If anything, studies like this empower people with knowledge. If a sugary drink is no longer just a harmless refreshment, but a potential accomplice to rogue cells, then choosing water, tea, or sparkling water becomes a kind of daily act of prevention. So, yes, sugar-sweetened beverages may be the uninvited troublemakers at the colon's party, but now we know how they sneak in and stir up trouble. With that knowledge, we can do more to keep the guest list healthy, not just by reducing the sugars we consume, but by supporting future treatments that starve cancer cells of their favorite fuel. This is a story that ultimately gives more hope than fear. It shows that science is catching up with the subtle ways our food and drink influence health, and every new discovery opens a new door toward prevention, treatment, and living better for longer.